Welcome students, welcome to this ninth lecture of non-traditional machining process. This lecture we are going to see about laser beam machining. Let us see what are the contents of this lecture. So we are going to see about the history of laser, introduction to laser, then the characteristics of laser, then the physical principle of laser. First let's see the history of laser. So the first laser was built in 1960 by Theodore H. Maiman at Hughes Research Laboratories and based on theoretical work by Charles Hard Towns and Arthur Leonard Shallow. And this is the Theodore H. Maiman with his laser in July 1960. And this was the world's first laser, okay, in May 16, 1960 in California, and this was by this Theodore H. Maiman. Now let's go to the introduction to laser. So laser is an abbreviation term and its full form is light amplification by simulated emission of radiation. It means light amplification by stimulated emission of radiation. So it is a device for producing a narrow beam of light capable of traveling over vast distances without dispersion. So it means narrow, and there is a two terms we are using here. It means narrow beam of light and without dispersion. So dispersion means without the light being dispersed. That's narrow. It means a single line. The single line of light. It can be capable of traveling over a long distance without any dispersion. This is one of the good characteristics of a laser. So it is also capable of being focused to give enormous power densities. It means 10 to the power 8 watts per centimeter square for high energy lasers. Okay, it can be capable of being focused to give a high or enormous power densities. A laser converts electrical energy into a highly coherent light beam. So laser beams works on the principle that it converts the in given electrical energy into a highly coherent light beam. Let's see each and every terms. Let's see a characteristics of the laser. A laser beam has the following characteristics. Are the following properties. A laser beam is highly monochromatic. It is highly monochromatic. Monochromatic means it can produce only one color or any one color. Okay, not a single color. It can produce any one color at a time, not multicolors. One laser light or one laser device can produce one color at a time. And the laser light rays highly pure beam of light, and it is a highly pure beam of light. So it converts the electric energy into the output will be comes in the form of a pure beam of light. It means electrical energy is converted into light energy. It is an intense beam of light. So intense means a thick, high beam. Okay, so we have a different type of beams of light. For example, in our house also we having a different beam of light in different watts, for 50 watts for light at 40 watts, 100 watts like that. But same time the laser it produces a high intense beam of light and highly directional. Directional means it can able to focus in any direction. It will not dispersed. So it can be focused to a long distance in a one directional and highly collimated. Collimated means a ray of light or particles made accurately parallel. It means a light ray or any particles, its flow or its run accurately parallel. not dispersed or diverged. It's flow in a parallel way. In next slide I'll show you this collimated and coherent. And the light produced by laser is coherent. The coherent means there are a number of rays inside the laser lights. In a laser lights, there are number of collective number of rays it can travel, but the collective number of rays it having a equal distance and equal intense. Each ray having an equal distance and equal characteristics and equal distance. So that means coherent, equal properties between the rays. Collimated means flow in a parallel path. All the rays flows in a same direction in parallel path. Coherence means having the rays having an equal characteristics. So these properties allows laser light to be focused using optical lens onto a very small spot with resulting high power densities. Based on these properties, the laser light is used to be focused and using optical lens onto a very small spot. You can spot very small spot resulting with high power densities. Now with the following with the characteristics of laser, let's see coherent, collimated and monochromatic, how it looks like. See, let us consider a rays. Okay, these are considered the light waves are like rays. Okay, coherent means, see, let's consider these three waves. These three waves having equal properties. Having it down, if it's the wave going down, wave going up, the same, all in the same movement, same characteristics. It means coherent. And then collimated. Collimated means all three rays goes in a parallel, not in any direction. All three rays goes in parallel. And monochromatic means all three are producing same color. All three are producing same color. Now it come to the second characteristics: coherent, non-collimated and monochromatic. And I tell you, this is not the characteristics of laser. These are some wave characteristics. Okay, but for laser, this is the actual characteristics of the laser. The other three are not the laser. But for better understanding, I will classify how the wave characters are. In second condition, let's see coherent, non-collimated and monochromatic. See, coherent means all three having the same properties, the ups and downs, but non-collimated. Non-collimated means it's not in a parallel, all having a different direction, all are start diverting, so it's not a collimated. But it is a monochromatic. Monochromatic means all three are same color. Chromatic means color, mono means single. It means all three having the same color, all three having the same wave properties. Okay, so it is called coherent. All three having the same color, so it is called monochromatic. But the direction was diverted, so it is not parallel, so it is non-collimated. Next, third, incoherent, collimated, monochromatic. See, this is an example for incoherent, collimated and monochromatic. Incoherent. Now you can see the three waves. Three waves having the properties of different properties. One having like this, and the second wave having first wave having when the first wave going down, the second wave is going up, and the third wave again going down. So all having a different properties. Okay, so it is incoherent. Collimated, yes, it is collimated. All three are moves in a parallel plot and in same direction. Monochromatic, yes, it is monochromatic. Means all three having same color. Let's see the fourth one: incoherent, collimated and non-monochromatic. Incoherent, can you see all three having different properties? Yes, all three having the different properties. But collimated, yes, it is collimated. It means all three flows in the same direction in parallel path. But it is non-monochromatic. Non-monochromatic means all three are different colors. Monochromatic means having same color, but it is non-monochromatic. It means all three are different color. When compared to all the four, laser having this characters. It having coherent, collimated and monochromatic. All the waves having its same property and qualities, and all the waves, all the rays flows in a straight line in a parallel path, and all the rays having a monochromatic light. It means same single light, single color. Now let's see the physical principle of laser. Consider an atom of a solid laser medium. Let us consider atom. Okay. If the atom or molecule of a solid medium does not emit energy, it is said to be in a lower energy state or ground state. Okay. So let us consider atom. Here there are different energy levels in the chemical in the atomic characteristics. Okay, different energy levels. For example, this is the lower energy level or ground state, and this is E2 middle level, and this is E3. And if you can go for E4, E5 like that. That means there is a higher energy level or excited state. We can say that now excited means I'm going to the high level. So excited state. This is the normal distribution of the atoms. Normal distribution of the electrons. Okay. Normally, now all the atoms or molecules, they are distributed, they are said to be in a lower energy state or ground state. All the electrons of such an atom occupy orbit that have lowest potential energy, and at 0 degree Kelvin all the electrons are in the ground state. Okay, and these electrons of the atom of an atoms normally it occupies the orbit is having the lowest potential energy. Normally it occurs in the lowest potential energy, and also at 0 degree Kelvin all the electrons are in the ground state only. Normally this is the normal state. More in some cases, some electrons or atoms present in the E2 or E3, but very less only. The possibilities are less only, but majority of the electrons in an atom, they can occupy it in the lowest energy state. The electrons at the ground state can be excited to higher energy state by observing energy of various forms. Okay, the electrons. Now these electrons in the ground state, it absorbs energy of any form, so that once it absorbs the energy, these electrons will move to the excited state. Okay. So the energy can be absorbed through vibrations at high temperature by chemical reactions with other atoms, or by collisions with other atoms by absorption of photons. Okay, this energy may be in the form of any form through vibrations at higher temperature. Okay, when the atoms are getting vibrated, the high temperature will produce through that high temperature the energy will be absorbed, or by chemical reaction with other atoms, or with the collision with the other atoms, or with the absorption of photons from the external side or external force. Okay, so this energy can be in the form of different energy. The energy means the energy which absorbed by the electrons. So when energy from the light source is made to fall on the solid medium, the atoms of the medium absorbs radiation. Okay, for example, when a light source or any photons it instant on the atoms, so that the atoms absorb energy. The same atoms in the lowest energy level absorbs energy, so that the electrons get also absorbs energy. As a result, the electrons of the atoms of the medium jump to a higher energy level. So when the electrons present in the atoms, it absorbs photons, it jumps to the higher energy level. And these atoms which have absorbed higher energy are said to be in the excited state. And once these atoms moves to the higher energy level, these atoms are said to be in the excited state. Let's see the small animation of how the photons how the electrons absorb photons, and it's going back to the and going jump to the higher energy level. Okay, so for example, once when once when the photon is incident on the electrons, these electrons get energized and it moves up to the excited state. Now this excited state atom spontaneously returns to the ground state energy by emitting a photon. Once the excited atoms spontaneously it will come back to the ground state. Okay, once it reaches the excited state and again spontaneously it comes to the ground state by emitting a photon with a frequency proportional to the energy difference between the excited state and the lower state. The energy, the photon which emitted by the same excited atom is equal to the frequency, which is the energy difference between this excited state and the ground state. That these the difference between these two frequency level will be equal to the photon release. So it means in the simplest case, the substance will return directly to the ground state. This electron will come to the ground state by emitting a photon with the same frequency as the observed photon. Okay, that photon also having the same frequency of the observed photon. At the same time, in a laser, the atom or molecules are excited so that more of them are at higher energy level than at lower energy levels. This condition is known as inverted population. Now we are considering this as an inverted population. Inverted population means the population from here initially at the ground state, but during this excited condition, excited means when energy or when energy is observed, all the electrons or most of the electrons it's moved to the higher energy level. It is population is inverted from the lower energy level to the higher energy. Okay, so this is called as an inverted population. Let's see how it's occurs. Okay, so now the thing is when the same electrons when it moves from top to that's higher energy level to the lower energy level, the same electrons it also release the photons. That photons equal to that photons energy is equal to the observed photon energy. Okay, when the same electrons when it observe the photon move or jump to the higher energy level, and spontaneously that electrons in the higher energy level moves or come back to the ground level, and the same time it will release the same photon which energy is also equal to the observed photon. Once the atoms or molecules are in this excited state, they readily emit radiation. Okay. Once the atoms or molecules in this excited state, okay, this if it is in the excited state, they readily emit radiation. They readily emit radiation means in the form of photons only. Radiation. Photons means the light waves travels through photons only. So when it's moving, when the electrons absorb photon, it's move up to the higher state. And when the same electrons coming back spontaneously with its own by its own spontaneously, that also emit photons. Photons means again light. It emit light, emit radiation. And if a photon's whose frequency corresponding to the energy difference between the excited state and the ground state strikes an excited atom, the atom is stimulated to emit a second photon of the same characteristics. It means if the same electron is coming down, the same time it emits a photon, it means emit radiation, light. That photon also will able to induce the other electrons to move to the higher energy state, and that is coming down. That again, that again will produce again will emit the photon. This happened continuously, once going up and releasing the observing photon, going up and again coming down, releasing the photon, and the same photon is incident on the other electrons. Again, it's going up and again it's coming down. So it's like a chain process. You can see. So this is coming down, releasing photon, and this photon is on the other electrons, and this electron is going up, and this photon will incident on the other electron. It's continuously happen inside the control volume. So the bombarding photon and the emitting photon each may then strike other excited atoms, stimulating further emission of photons of all the same frequencies and in phase. So this action happened continuously. Initially, it absorbs photons and it's go to the excited state, and coming back, while coming back, it releases photons, and that same photon is incident on the other electrons. That again going back and jump to the higher excited state. So it is continuously happening, and stimulation. Stimulation means continuous emission of photons, continuous emission of going the excited state, ground going to ground level, going to excited state. So these, as all the excited atom release photons in the form of a chain. So all these atoms released photons in the form of a chain. It's a chain reaction, continuously emits photons. Okay, and finally, this produces a steady beam of coherent light called the laser beam. Okay, and finally, all this happened in a controlled volume or a controlled device. So all this happened continuously, and finally, it will produce a laser beam. It's this chain. This atoms, excited atom, release photons in the form of a chain reaction. So continuously photons releases, and this produces steady beam of a coherent, equal characteristics, and a collimated. It means a parallel beam of a light, and it's called a and it having an intense beam. That beam having an intense characteristic of light, and that beam is called as a laser beam. That is a light amplification and stimulating emitting radiation. Now let's come to the summary. We start with the introduction to laser and the history of laser and the characteristics of laser and the physical principle of laser, how the laser light is happening or producing in the actual system. And this is the reference which I used for this lecture. And thank you, students. Thank you for this lecture. We'll see you in the next class.